So taking a look at section 2.1 part 2, just a quick reminder, if we're asked for the tan of angle C, I'm going to identify angle C on my triangle, and tan tells me that it's going to be a ratio of the opposite side length to angle C divided by the adjacent side length to angle C. And so I can use tan of an angle to solve for a ratio. And so if I can solve for a ratio given an angle, I should be able to do the reverse process. I should be able to figure out what the angle is that produces a particular ratio. And the way I do that is using the inverse function. So in this case, I want to do the inverse of tan. And to type that in on a calculator, you often have to enter second and then find the inverse tan function. It kind of looks like tan to the power of -1. And so that is representing how I would type in the inverse tan. And so what this allows me to do is say that the tan of angle C is 39/17. Well, that must mean that angle C is the inverse tan of 39/17. And if you punch that into your calculator, you should get 66.45 degrees. Okay, and if you're coming up with something other than that, it means that you're likely in radian mode. And so make sure you switch modes on your calculator. Either push the mode button and on a graphing calculator and switch radians to degrees. Okay, and so if I do the other angle for tan of angle R, then opposite to angle R is 17, and the adjacent side to angle R is 39 inches long, so 17/39. And so that means that angle R is going to be the inverse tan of 17/39. And that turns out to be 23.55 degrees. And that should make sense because the sum of any angles in a triangle are going to sum to 180 degrees. And since we have that 90-degree angle already in a right triangle, that must mean angle C and angle R must add to 90 degrees as well. And so if we ever have two angles that add to 90 degrees, we call those complementary angles. And so the acute angles in a right triangle are always going to be complementary to each other. And so in this case, that's angle C and angle R.